Another traveler from a foreign star system is already heading toward us. 3I Atlas, the third confirmed interstellar object we have caught after the enigmatic Oumuamua and the icy 2I Borisov. Hi everyone, this is the Space Channel, and today we will figure out where 3I Atlas comes from, why its trajectory alarms astrophysicists, and what new chapter it opens in our understanding of the cosmos. Well then, let's go explore 3I Atlas. In just 8 years, humanity has for the third time noticed a body that was born near an entirely different star and is now dropping by our neighborhood for a short visit. To feel the scale of the event, let's recall how it all began. In October 2017, the Hawaiian telescope Pan-STARRS-1 discovered a tiny, faint speck that was named Oumuamua, Hawaiian for scout messenger that goes ahead. This object moved along a hyperbolic orbit, the kind that points to an interstellar origin, and it was not gravitationally bound to the Sun. Astronomers observed that during one full rotation, the brightness of Oumuamua changed almost tenfold, brightening and dimming. To give such a contrast, the body had to be very elongated. Initial estimates suggested proportions of about a 10-to-1. In the news, it was described as a cigar-shaped interstellar object. However, later solutions proposed it might be flat like a pancake. The symbolic cigar, with no cometary coma at all, was hailed as a cosmic oddity. Theorists assumed such guests fly past us extremely rarely, perhaps once in several decades, and the chance of spotting them was practically zero. 2 years later, fate made another, this time more eloquent gesture. On the night of 30 August 2019, the former Ukrainian amateur astronomer Gennady Borisov, working at his private Crimean observatory Margot, photographed a comet. The 65-centimeter telescope he had built with his own hands was designed specifically for hunting fast and faint objects, and that very design presented the world with the first confirmed interstellar comet, 2I Borisov. Unlike Oumuamua, it looked almost ordinary, active with a coma and a tail. But the gas spectra immediately revealed an alien registration. The gaseous envelope contained an abnormally large amount of carbon monoxide relative to water vapor, as though the nucleus had formed in a colder region than the Kuiper Belt. And now, on the 1st of July 2025, the Atlas Automatic System at Rio Hurtado, Chile, has recorded yet another celestial wanderer, 3I Atlas. By the way, ATLAS stands for Asteroid Terrestrial-impact Last Alert System, a fully robotic network of small yet extremely nimble telescopes created by the University of Hawaii's Institute for Astronomy and funded by NASA to comb the whole sky every night in search of threatening space rocks. Each of the four, as of 2025, already 0.5-meter reflectors, covers about a 5-degree patch of sky in one exposure and scans it roughly once per night. Thus, the network provides uninterrupted coverage of the daily cycle. All the work, from pointing and exposure to computer comparison of new frames with the Starfield database, takes place without human intervention. Operators only check the automatic alert pings before the data is sent to the Minor Planet Center. The first 2 Atlas telescopes started up in Hawaii in 2017, and when the program proved it could really warn of potentially dangerous asteroids just days or even weeks before an Earth approach, NASA funded an expansion into the southern hemisphere. Now the network consists of the Hawaiian pair, Haleakala and Mauna Loa, instruments in Chile, South Africa, and the newest telescope on Tenerife, thanks to which the far south dead zone has disappeared, and the whole sky is scanned every evening. On ordinary days, ATLAS diligently counts asteroids, but the system's fame also comes from pleasant surprises, such as the detection of 3I Atlas, which observatories worldwide are now watching. In short, ATLAS is an automatic planetary defense alarm system, and at the same time an all-seeing eye that lets us catch guests even from beyond the solar system ever more often. So on the 1st of July 2025, the Chilean Atlas telescope saw only a faint dot in the image. It could have been anything: an asteroid, a comet, stellar noise. At this stage, they simply marked a new object. A weak coma, however, was recorded on 2 July by independent telescopes, after which the Minor Planet Center labeled the object C2025N1 Atlas and granted it comet status. A few days later, calculations showed an eccentricity noticeably greater than 1. The body is flying along an open, hyperbolic trajectory, so it has never been gravitationally bound to the Sun, and after its passage will vanish forever. 2 days after the discovery of 3I Atlas, the team of the European Southern Observatory re-aimed the Very Large Telescope at the new object. It was the deep night of the 3rd of July 2025 when the FORCE 2 instrument began taking a sequence of short exposures, roughly 28 frames of 30 seconds each. Astronomers deliberately observed using fixed stellar coordinates rather than the comet's changing coordinates, so 3I Atlas shifted farther to the right in each frame, leaving a tiny dot where it had just been. When these frames were merged into a 4-second time-lapse, the video clearly showed a motionless stellar backdrop and a single blot, the comet, gradually shifting from frame to frame. This simple clip vividly demonstrates the insanely high proper speed of this interstellar guest. In just 14 minutes of real time, the object moved roughly 5 arc-seconds, more than ordinary comets cover in an entire hour. Yet the time-lapse is valuable not only as eye-catching footage for social media. Every recorded position of the comet supplies a point for orbital calculations. Thanks to such early astrometric measurements, it was possible to prove with confidence that the object's eccentricity exceeds 1, so this body has never been bound to the Sun. The International Astronomical Union then changed the prefix C, comet, to 3I, interstellar, but the letter I merely fixes the extrasolar origin. It does not cancel the object's cometness. Unlike the dry, enigmatic Oumuamua, which showed no coma, 3I Atlas behaves exactly like an icy fragment. Simultaneously, brightness and light scattering were measured in different filters, the first hints at the coma's composition, now folded into observing plans for Hubble and James Webb. Thus, a few dozen frames shot by the VLT in the Chilean desert fulfilled 2 roles at once. They gave the public the most expressive live look at an interstellar wanderer and gave scientists the critically important data, without which there would be neither a precise orbital solution nor certainty that we are indeed seeing the 3rd interstellar object in the history of astronomy. Based on this, cosmic observatories are already lining up to find out what kinds of ice and gas 3I Atlas is carrying from the depths of the galaxy. To gauge how sharply the celestial guest 3I Atlas stands out against known solar system bodies, one need only glance at its speed. Uranus, for instance, moves calmly along its orbit at about 6.8 kilometers per second. 3I Atlas, however, travels at roughly 57 to 58 kilometers per second, the so-called hyperbolic excess with which it entered our system. And when it reaches perihelion around October 30th, it will accelerate to nearly 68 kilometers per second, more than 10 times faster than Uranus. Such a furious pace of motion confirms the object's interstellar origin even more strongly than the mere fact of its hyperbolic orbit. No less striking is the comet's possible nucleus size. Although estimates remain imprecise, the active coma hides the solid core. The tentative limits are these. The minimum diameter may be about 1 kilometer, and photometric data put the maximum at 20 to 25 kilometers. Meanwhile, most working estimates now cluster in the 1 to 4 kilometer range. Even in the most modest scenario, the nucleus is at least twice as large as that of Comet 2I Borisov, whose diameter, according to Hubble, did not exceed 0.4 to 0.5 kilometers. And if the upper limit of several dozen kilometers is confirmed, 3I Atlas will become a true giant among interstellar objects, far outsizing Borisov. As for Oumuamua, the first messenger of 2017, the same cosmic cigar, its length was estimated at no more than 200 to 400 meters, and its equivalent diameter at mere tens, not hundreds, of meters. Thus, compared with it, 3I Atlas is not only the fastest, but also potentially the largest interstellar traveler among the three we have managed to catch in one decade. Further analysis added historical weight to the discovery. Data on velocity and flight direction were run through the so-called Otautahi Oxford model, a new statistical approach that correlates trajectories of interstellar bodies with different components of the galaxy. The model pointed, with high probability, to the Milky Way's thick disk, a region where stars that formed long before the Sun are circling. Early ground-based analyses already hint that beneath the thin dust layer lies a rich reserve of ice. As soon as 3I Atlas nears the Sun, various ices, H2O, carbon dioxide, ammonia, will start to sublimate, producing vapor and gases in the coma. The high humidity of the coma, in other words, a large fraction of water vapor in the volatile mix, powerfully attracts planetary scientists. Such material, frozen even before the first generations of stars, can reveal what the galaxy's chemistry was like in the early epoch when the first planetary systems were forming. If 3 billion years ago Atlas really shot out of the Milky Way's thick disk, its ice may be at least 3 billion years older than our planetary system, and rough estimates place the fragment's birth in the era 8 to 11 billion years ago. This makes the present visitor the most ancient comet ever observed by humankind, a kind of cryogenic capsule from the very early youth of our galaxy. The most exciting part is still ahead. When, on July 1st, 2025, the discovery of the third interstellar object 3I Atlas was announced, Avi Loeb, the Israeli-American cosmologist, together with two co-authors, released a preprint about it. The researchers calculated that the trajectory of 3I Atlas passes astonishingly close to Venus, Mars, and Jupiter, and the probability of such a coincidence does not exceed approximately 0.005%. Moreover, its orbital plane has a small retrograde tilt relative to the ecliptic, which, in the author's view, would give an extraterrestrial intelligence a convenient path to approach Earth unhindered. When the object reaches perihelion, its closest point to the Sun, and is hidden from Earth-based observers in solar glare, it could theoretically execute a covert reverse Oberth maneuver, a powerful braking that allows an interstellar craft to remain in orbit around our star. The optimal interception route to Earth, by their estimates, would bring arrival in late November, early December 2025. And if, after perihelion, a slight non-gravitational acceleration is observed, approximately 5.9 times 10 to the minus 5 astronomical units per day squared, reduced to 1 astronomical unit. This, the authors say, might indicate the object's intent to intercept Jupiter and later draw closer to it. How should one respond to such a claim? It is worth noting that Avi Loeb's hypotheses usually reach the press before they undergo strict peer review. They rely on anomalies that may have more mundane explanations, and he actively cultivates his personal brand, from book tours to crypto-millionaire-sponsored expeditions. In 2017, the interstellar object 1I Oumuamua flew through the solar system. Loeb focused on its high-speed, unconventional shape and unnatural acceleration without a visible gas trail, and proposed it was a fragment of an alien light sail. He popularized his idea in the bestseller Extraterrestrial, 2021, and continued in Interstellar, 2023. Loeb embarked on a series of public lectures and presentations, speaking at venues such as San Francisco's Commonwealth Club, the Chicago Humanities Festival, Harvard's Museum of Science, and New York's Stryker Center, as well as participating in podcast interviews and autograph sessions. This is a typical book tour, an author traveling widely to promote a book and strengthen a personal brand. In 2023, Loeb led the Galileo Project expedition to the Pacific near Papua New Guinea to recover microspherules he believes are fragments of the interstellar meteor IM-1. The trip was funded by Charles Hoskinson, Ethereum co-founder and Cardano blockchain creator, who provided approximately $1.5 million for the vessel, equipment, and a film crew. In short, Loeb monetizes hype. Of course, intelligent life could exist in space, and even Loeb's strictest critics admit this. But rhetoric such as the first proof of alien technology without ironclad data turns scientific inquiry into a media talk show rather than a rigorous experiment. As Paul M. Sutter, cosmologist, author, host, and U.S. cultural ambassador, summarized, the hypothesis aliens did it is bad science not because aliens are impossible, but because it cannot be tested more easily than the many natural alternatives. Colleagues' chief complaint against Loeb is the leap from an object's anomaly straight to the most exotic explanation, coupled with hyper-mediatization, unsupported by the necessary level of evidence. At present, observing 3I Atlas requires at least a 20-centimeter amateur telescope and genuinely dark skies. In August and September 2025, from U.S. territory, this will be possible right after evening twilight. That is, when the sun has dipped more than 18 degrees below the horizon, and the sky reaches maximum natural darkness for mid-U.S. latitudes in August-September, that is roughly 1 to 1.5 hours after official sunset. Exact duration depends on date and latitude. On the sky map, this is the region of Ophiuchus and Sagittarius. NASA forecasts that ground-based observations are still feasible in this period before the comet disappears behind the sun. In early October, 31 Atlas will draw closer to the sun. Elongation will become so small that the object will vanish in solar glare. Perihelion falls on 29th October, and until the second decade of November, the comet cannot be observed from Earth. Exactly then, according to JPL calculations, it will pass Mars at less than 0.2 astronomical units and reach its maximum velocity relative to the Sun. At the beginning of December 2025, the interstellar object 3I Atlas will already have emerged from behind the Sun and will shift from the constellation Virgo into Leo. For instance, in Chicago on the 10th of December, at about 5:30 in the morning local time, Stellarium shows our comet a little over 50 degrees above the horizon, provided you can avoid the city's bright skyline. The on-screen magnitude is approximately 15. Earlier forecasts mentioned around 14, and even 11 to 12. But the real brightness depends on how fast dust and gas are released, something almost impossible to predict in advance. In addition, information on 3I Atlas is updated constantly, so recheck the data nearer the observing date. In any case, the object will remain faint. You will need a telescope at least 15 to 20 centimeters in aperture and truly dark skies. The exact simulation gives a distance of about 1.82 astronomical units, nearly 274 million kilometers. That is normal for interstellar visitors, poses no danger, yet is astronomically intriguing. This is the period when it is easiest to measure intrinsic brightness, gauge speed, and refine the orbit. At the same time, the comet is still relatively close. Across the continental United States, the comet's altitude will vary little, about 10 degrees higher in the southern states and roughly the same amount lower in the far north, so the 40 to 50 degree range will hold for most observing sites nationwide. Two conditions remain crucial: the darkest sky possible and the hour before dawn, when background light is still weak, but the comet has already climbed high. In practice, from early December to the Christmas holidays, this morning slot will be the main window in which 3I Atlas can delight telescope-toting amateurs in most major U.S. cities. Besides 3I Atlas, the second half of 2025 will offer several other eye-catching targets for amateur telescopes and even the naked eye. In August, Saturn will dominate the sky. On 21st September, Earth will pass between it and the Sun. So the planet reaches opposition, glows at approximately plus 0.4 magnitude, and stands high in Aquarius. At the same time, note the Perseids, peak night 12th and 13th August. The moon will be almost full, washing out the fainter streaks, but bright fireballs will still punch through the lunar glare. September brings two blue oppositions. Neptune on 23rd September, 7.8 magnitude, and Uranus on 21st November, 5.7 magnitude. Both are invisible to the unaided eye, yet in a 15-centimeter mirror look like tiny turquoise disks. On the night of September 7th, try to catch the total lunar eclipse. Hawaii and most of Alaska will see it fully. In the continental states, only the initial penumbral phase, or nothing at all, will be visible. October features two active meteor showers. The Orionids, peak from 22nd to 23rd October, delight with swift, bright traces, and the young crescent moon, only 2%, leaves the sky dark. Next come the Taurids, famous for slow fireballs. Their maximum is 3 to 4 November, but this time an almost full moon will hamper observations. In November, a super full moon returns. On the 5th of November, the moon reaches perigee and is simultaneously full, appearing a few percent larger and brighter. Toward month's end, Jupiter, though not yet at opposition, that comes on 10th January 2026, will already blaze in the morning sky, outshining every star. Finally, 14th December, Geminids. This reliable December shower radiates from near the twin stars Castor and Pollux. In 2025, the moon's phase gives moderate interference. On a clear night, expect 50+ meteors per hour. At the same time, the U.S. winter sky lifts the classic bright objects of the season: the Orion Nebula, M42, the Pleiades, M45, and Andromeda, M31, all splendid in binoculars. Positions and brightnesses of celestial bodies are updated regularly. Before observing, refresh the ephemerides in Stellarium or another planetarium. Comet magnitudes and meteor shower rates are especially sensitive to real-time dust and gas activity that is hard to foresee. So 3I Atlas, the third known interstellar object, and apparently the largest humanity has ever recorded, is best attempted in the first half of December 2025. By then, the comet will be slightly brighter, high enough above the horizon, and no longer lost in solar glare. Choose a site with minimal light pollution, say, the New Mexico desert or a mountain plateau in Arizona. Wait for a moonless night, set up your telescope, and try to glimpse this traveler from beyond the solar system. For its appearance reminds us that space is a dynamic, surprise-filled arena where galaxy-scale events can unfold before our very eyes. 3I Atlas is a window into the deep past, an era when the first stars and planetary systems were forming. Every new observation brings us closer to understanding yet another page in the history of our universe. That's where we'll wrap up. Thank you for watching. Your support motivates us to create more reviews about real events in space. If you found this episode interesting, give it a like, subscribe, and hit the bell so you don't miss new data on 3I Atlas from Hubble and James Webb. Leave your thoughts and questions in the comments, and together we'll keep uncovering the universe's secrets. May you all enjoy clear skies and happy observing.